Okay, good morning, everyone. We will start on time. So, I am doing a recording on this. So, for those who object to recording, I think you can exit from this webinar because there are some who cannot attend the sessions. So, actually, I'm doing some recording. So, firstly, rules and regulation. I think you can read yourself first. But the way that I want to strategize this webinar is that this is my first time that I'm doing questions and answers. Last year, actually, when I started with this module, it's not so complete. Less of the topics are covered, and I don't have so many questions in hand. So actually, I only went through one session trying to condense all the concepts that the candidates should actually know before they attempt the exam, but I think they are not too helpful also. I think one of the guy who took my last year who took my this pre-recorded webinar, he passed. But I think it's because his strategy is to concentrate on questions. So to attempt more questions and to have practice. So what this guy did is that he actually had gathered some past year questions and some that he didn't know how to answer. He actually shared with me. So actually I got questions. So actually I've been collecting the past year questions also from people. So I hope that for you all who are taking the exam this year, and then when you finish all these things, maybe you can email me the questions before you forget, so that if you pass the exam, I'm very happy for you. But those who don't, all these things, then at least we have more questions to fall back on. So some questions are kind of like pretty repetitive. So I think last year, I think the hot water question came out again. And that was the exact question that the candidate asked me before he went for exam. So I would guess that the one of the reason that we don't get a lot of past year questions, like it's not available at the web, all these things for you to download. I think it's because there's limited questions that have been circulating around. So probably it's like they would actually, like the questions would actually come out again, like maybe like after like maybe this year, then maybe next year it could be the same again, or the year after that. So that's why I think they have this limit of, I heard that you need, if you pass one paper, you need like within 3 years, then you have to pass the rest of the papers, all these things, to be able to qualify for your PPC. If not, then you have to restart again. So I always ask why the questions are not available, and actually somebody from the IEM, people up there committee or past chairmanship, chat to me that some of the questions are repetitive, so there are limited questions. So actually, I have actually gathered past year questions also. So those I won't go through again. I think you go through them, all these things. And then if you have questions, all these things, I believe that you have gone through them now. Some of you all, you can ask questions at the end of this session. So actually, I actually don't intend to pack up the whole 2 hours with my questions and answers. You go through some of it, the concepts, but I think that there should be enough time for you all to ask questions. So the one that I go through will be your weekly questions, which I hope that you are doing. So actually, the way that it works is that some people ask me why need to take so much time. So actually, for me, it's that don't jam pack everything into last minute, because it's your retention is less if you don't have practice. So if you jam pack everything into last minute, then you learn all the concepts, but you don't have the time to practice the questions, all these things. They don't stick to you. So you would, like, maybe during exam when you get asked questions, then you need to flip around all these things. So that takes up a lot of time. So the way that this thing works is that you go through the module one by one in terms of the training program that I've given you, all these things. You may actually go through a few, like you choose. If you don't have time, you can go through a few, but don't jam pack like everything into like the last month of your exam or last week of your exam, and then next week you're going to take the exam. Don't jam pack that. I think is not actually very advisable to jam pack the thing. So I will start with these questions. I will just go through some questions and then how I handle them. So we go through the concepts that actually this most of the concepts are actually covered in the presentation materials, all these things, my pre-recorded webinar module 1 to module 4. So then I will show you how to relate, correlate, and use those what you have learned into answering questions, how you answer questions. But first and foremost is that don't pack everything into last minute. And then it's like, hopefully it's like by the last day, all these things before next day, say like next day is your exam. I think it's no point like sleeping late, all these things. I think better have a good night's sleep, all this. Wake up fresh, and then at least it's like your brain works much better the next day if you have enough rest. So let's go into the questions. For those who are actually joining all these things, this thing is actually being recorded. So the first one we go through is cold water, because I think module 1 we have actually cold water. So actually all this some of the informations, most of the informations are actually available on the actually the module 1 to module 4 pre-recorded webinars. And some may be a bit new materials, all these things, because I cannot actually put everything into the pre-recorded webinars in like 4-hour session. Sometimes we just can't make it. So actually, let's start the slideshows. Okay, so this is the questions that we have for the first week. So if you are doing a cold water, all these things, at the end of after you have done the module, then you should attempt the question. So this is one of the typical questions. So all these questions here in the quiz that I have here, they are actually not past exam questions. Past exam questions are actually given also, but they are actually what people can remember. So this is actually what I developed, what I think that people should know, because as far as I know, this PPC is for basically for those people who want to go into design and submission. So if you need to submit, you cannot use your hexagonal chalk, you need to use your round chalk. Okay. So this first question here is we go through the questions and then we go through the answers. So what's the design storage tank capacity for a school with 500 students and minimum 3 days storage required by Jabatan Air? Okay, so if you go into this one, the first thing is that you need to have in hand actually your you normally get it from span table. In Malaysia, we use span. I think there's no change since the last one. I think is was it like 2008 or 2018? I think span came out in 2018. And it has never changed. So there's only one version so far I've seen of a span. So actually the table that you refer to when you said that for M&E, we are designing for internal plumbing. So for internal plumbing, always use table C. Okay, there are two tables, they look similar. One is table B, one is table C. But I think most of the things are similar. But but I did not check each and every single one. Safest is always use table C. So you have your table C. I think I put the table C, all the table C's information into your notes. Tag those notes, okay? So that when your question comes out, you can actually refer. Okay, so for this, for example, if you look at the notes, I think there's one table C here. So they are actually like if you have 500 students, so actually it's actually a school. So the first thing you check is school. This is basic, all these things are school. So it should be education other than schools and kindergarten, day schools and kindergarten. So it's day schools. So actually what you always need to know is that if you have a table that shows one is the day school and one is hostel, all these things, actually is the hostel is the one I think requiring more water, because actually in day school your students don't stay overnight. Okay, it's the same thing with hospitals. When they are beds, you need more water. Is the amount of water per beds. Okay, so this let's say if a minimum storage, let's say your Jabatan Air needs 3 days. So this question asks for 3 days. So you have 500. Then you go and check this thing is 30 per person, 500 person by 3 days. So actually, how much you want to design for your suction and elevator is still up to you. So normally we'll just do suction is 1/3, elevation is 2/3. Okay. So normally that's what we do because we do not want the pump to be always like working too hard. Because if your elevated water tank is very small and your suction is very big, so the water tank at the top always clear out, and then your pump always need to pump whenever the water is clearing, because you don't pump all the time. You pump when the water is low level at the top there, and then you stop when the tank is full. So you, if that start stop time is too little, all these things, then your pump will always be working, so it's actually not good. So normally is that I have also done about 50-50%. So it's actually there is no rule of thumb, is still up to you, but you need to know what is the pro and cons. But the cons to have like a very very big elevated tank is that your elevated tank will actually constitute weight, and then that weight actually will add on to the cost of the structure. So that's just a bit of extras. Okay, so this is how you do this thing. And then the next question is that they ask you that the elevated tank platform is 28 meters. So that means 28 meter is the bottom of the elevated tank. And then you know that your water level, there's actually 5 meter water level. So your top water level is what? 28 plus 5 meter. And then your design the suction tank, elevated tank, and pump size for the above exercise, assuming pump duration to not exceed 10 hours. Sorry, actually it's in the, so include also the control, how you want to control the pump. Okay, and assume that your pump and suction tank is co-located at 0 meter level. So you know that your flow rate for 10 hours is actually, you do not take your whatever, you actually take your daily demand. So your daily demand actually is one day is 15,000. So it's you want that pump to work maximum 10 hours only. So 15,000 liters divided by 10 hours, so it's 25 liters per minute. Okay, and the static head, that means what your pump need to pump from your low level, the suction level, to your tank, your elevated tank level. So this is your 28 meter plus 5 meter of water, and minus zero. Zero is actually for your let's say your, for your suction tank and your pump. So we assume there's no whatever there's no positive head gain. But normally there's just very little, but it makes no difference. And then after that, you need to assume a pipe diameter. So normally, if you are intending to use mild steel cement, mild steel pipe, mild steel cement line, the smallest pipe is 100 mm. So you go for, you start first with 100. Let's say it's a 100 mm. And then if you use cement line, actually this 1C is equal to 120 is for Hazen-Williams equation. Okay, so the C actually is normally 120 for your mild steel. But actually, if it's to be more precise, for this for your cement line mild steel, the C is actually 130. You can check that in a table. This one you can extract simply the C value. You can Google the thing. L, let's say the length of the pipe actually is 33 meter. So it's from your pump. Let's say from your pump, all these things is, let's say is you know that you need to clear 28 meter. So let's say you need to give it an extra 5 meter for other lengths of but because you know that your vertical length is actually 28 meters. So let's say give an allowance 5 meter. So there's no exact all this, unless of course they give you a lot of data, all these things. So some of things you can assume all these things, but you just write down what is your assumption. So your friction loss, you need to use a Hazen-Williams equation. So actually Hazen-Williams equation are very important to know. So actually, I will suggest that you have this, you take this formula. So this one is the one that you use. This equation is the one that you use for SI. So the P actually is in bar, the pressure loss. L is in meter. Meter is inclusive of the length of the pipe and fittings. And then your C is actually normally you use 120 lah. Plastic pipe is 130 because they are more smooth. So your friction loss is less. And D is internal diameter is in millimeter. So your Q actually is in liters per minute. So this one, you when you do your friction loss calculation, be very careful of the units that you have here. Okay. So if there are actually many formats, but more or less the same, but the constant here is different. Why is it different? The constant here is different because of different units used. So actually for your, actually, I would suggest that you actually Google different forms of Hazen-Williams equation. Make sure that they are correct. You Google a few sites and then you put them all together. I can show you how I do it, all these things, but it can be done easily. So that if you have, let's say, if the questions come out in interior, all these things, that means it's in feet and all these things, then you don't become kelam kabut. You still actually have your Hazen-Williams equation to use, okay? So here actually I've calculated this is actually my loss is actually, if I use this equation, it's actually 0.002. Sometimes actually my calculations here may be wrong one, because if I use spreadsheets, all these things, some people have pointed out that it's wrong, all this. But never mind, make sure that you do your calculation yourself here. Don't follow whatever. Use the correct equation, okay? And here I use a factor of safety 1.5 for the fittings, okay? So it's still up to you, but qualify yourself. So it's actually a very small part. So actually you can see that for your, if you are doing your pumping, and then from a suction tank down there to elevator up there, so you know that static head is most of it, and your friction is actually a very, very small part. So actually the whole pump head that you require is 33.003 meter. I think I missed out the control. Okay, the control strategies of pumps, then you can actually explain. You can draw out the thing, you can explain. Okay, so for if you are doing this is called a water transfer. So you are transferring from one tank to another tank. Okay, so you are not actually serving people, you are not serving fittings. So the pump that's serving fittings is booster pump. So this one is transfer pump. So transfer pump, most of the time if you are doing building, both the tanks, let's say the suction and elevated tank, are actually quite close to each other. It's in the same building. So for here, it's probably about 33 meter, all these things. So what you use is normally that you use is because you are transferring water only. So what you use is actually a pump, and you use a level switch. So a level switch, there are two types of level switch. You can use a float level switch, or you can use an electrode sensor. But I think in span, if I'm not wrong, you are not allowed to use a float switch. So you just use the electrode sensor. So for you need to explain that when the water level at elevated tank is reach a low level, all these things, then your pump will start pumping. Except when the water level in your suction tank is very low, then you cut off the pump. And then the pump will pump until the water level reach the high water level that your electrode detects, okay? And then the pump will stop. So all these things you need to be able to explain, because I think it's very basic of design. Okay, the next thing that most people are not aware of is cavitation. Actually, cavitation actually is a problem that actually is a very common problem. Actually, I've come across also. So the way that this is just blasting, the way that you detect cavitation is that when you are running your pump, sometimes your pump is very noisy. It could be cavitation. And then what you do is that when you put a clamp meter, all these things, to the power supply, all these things, you would not you cannot actually, because the current that you detect will actually fluctuate, so it's not constant. So actually you know that something is not correct with the pump. Most of the time is because of a cavitation problem. So cavitation happens when your water, so remember that water actually boils at 100 degrees Celsius, but provided what? Because it's provided is atmospheric pressure. So when it's lower than atmospheric pressure, then the water could actually boil at a lower temperature. So cavitation actually means that the pressure that is actually at the inlet of your pump could actually drop below your atmospheric pressure. And if it drops so much, all these things, the water will start to boil. Okay, because the water, because the pressure there is lower than the vapor pressure, so your water vapor actually inside the water, the vapor pressure actually will escape. It will just become it will start to bubble all this, and then when the water become vapor, it goes through the impeller. Because impeller, what happens is that it will actually increase the pressure. So when the when the vapor come out, it's actually the pressure now is higher. When the pressure now is higher, the bubble will collapse. So that's why you get cavitation. Okay, so this is one of the big problem. So the questions actually ask you if the suction tank is located below the pump. So actually, when you have if the best way is always put your tank above the pump. Okay, if you have no choice but to put your tank below the pump, then you always need to calculate for cavitation. And then the other one that you need to calculate for cavitation actually is when actually your tank, suction tank, is too far from your pump. Then you got a lot of friction loss. So how you do the calculation, we show you here. So let's say the bottom water level of tank is 2 meters below pump. Okay, so that means you always don't take the top water level, you take the bottom water level. So because your pump is supposed to work up to the bottom water level, so if it's 2 meters below the pump, with the design pump size just now, suction pipe size which we have is 100 mm, calculate the net positive suction head available at the pump suction. So what is the pressure available? So net positive suction head, remember, is always an absolute pressure. It's not a gauge pressure. It's always relative to the atmospheric. So your net positive suction head available is what you have to start with is you got your atmospheric pressure. Atmospheric pressure is 1 bar, is actually a 10 meter. So actually, if you actually Google the vapor pressure of water, actually is very small if we are working at 20 degrees Celsius. But then if you are working at hot water, 70 or 80, all these things, it could be quite substantial. So you need to be careful with that. You need to minus off the vapor pressure at the temperature that you are working your pump. And then you need to minus off the static loss, because this